Hi, good morning. Thank you very much for the introduction, Laszlo and Lincoln. I just wanted to say how delighted I am to present today on the Ontario Tumour Bank. And the presentation title is Your Research Partner for Quality Biospecimens and Data. Okay, just a quick overview of my presentation then. I'll talk a little bit about the vision and mission of the Ontario Tumour Bank, also about how we collect samples and data from participants. How does a researcher access our samples and services? And then what are some evolving trends in the area of biospecimen supportive research? So as Lincoln mentioned, the Ontario Tumour Bank has been part of the OICR actually since OICR started, in fact, predates OICR. We've been around for almost 20 years now. In fact, next year is our 20th anniversary. So how do we operate? OTB has always been extremely collaborative. So what we do is we partner with Ontario hospitals. Currently, we're partnering right now with the London Health Sciences Centre, St. Joseph's Healthcare in Hamilton, the Ottawa Hospital in Ottawa, and our newest partner coming on board will be Unity Health here in Toronto. And what we do at OICR is we serve as a central database and a distribution center for the samples and data to researchers. So how does it work? So patients are approached at the hospital sites. They're consented using a broad informed consent form by our clinical research coordinators at the hospital sites. And then this occurs typically prior to surgery or at an early time point during the care of a patient known or suspected with cancer. And then if they are having surgery, a preoperative blood sample is collected. And then on the day of surgery, we have biobank pathologist assistants. So these are very specially trained individuals who operate in surgical pathology under pathology supervision, and they sample the fresh surgical specimen and collect a portion of the tumor as well as a portion of the adjacent normal tissue. So then, and the reason that we consider it a high quality service is that we operate under standard operating procedures. So all of the sites have very uniform tissue and blood and sample collection and processing and storage procedures. So our vision then is to be a world-class repository of oncology samples and data. Our mission is to facilitate research in Ontario and beyond to improve the care of patients with cancer. So what do we have in our inventory to date? Again, as Lincoln mentioned, we have about 30 different solid tumor types, and all of our cases are prospectively annotated with clinical data. So just a rough overview, we are kind of opportunistic. In order for us to bank from a patient with a solid cancer, we cannot interfere with clinical diagnosis, number one. And secondly, the tumor has to be large enough that there's enough remnant tumor in that surgical specimen. So our biggest collections then are in the genitourinary cancer type, bladder, prostate, renal, and we do have some testicular cancers as well. We have a large number of gastrointestinal tumors, colorectal in particular. Gynecologic malignancies, we have a lot of endometrial tumors as well as ovarian cancer and others. And then in lung, we have mostly non-small cell carcinoma of the lung and a small number of mesothelioma tumors as well. We do have a large number of breast cases, and then as we go down the list, a smaller number of less common tumors or more difficult to access, and that is sarcomas, melanomas, endocrine tumors, and lymphomas, and so on. So as I mentioned, when we collect the samples, these samples are meaningless without detailed clinical data. So our staff at the hospital sites collect demographics on each of the patient, things like age, sex, age of diagnosis, sex, other demographic information about the patient, also comprehensive medical history. And then, of course, once the pathology report is signed out clinically, that data is extracted, and this includes the diagnosis, staging, and for some of our cases, we also have biomarker data. And then they follow up at 1 year and 2 years and 5 years after the surgical event, and they collect the treatment information. So did the patient receive chemotherapy and other treatments? And then how did they respond to that treatment? And the patients are followed for up to 5 years. So I mentioned that part of our collection is not only data, but also samples. So how does that look like? So if we start at the left-hand side of the diagram, then we have a broad informed consent process where patients with known or suspected cancer are approached by our clinical research coordinators. And as I mentioned, this broad consent allows not only academic research, but also industry research and also deep genomics. The preoperative blood is collected into an EDTA anticoagulant and processed in a buffy coat and plasma. The tumor on the day of surgery is collected. It is snap frozen and also put into a paraffin block. And from that paraffin block, an H&E is cut and the slide is digitally scanned into our archive. And then, as I mentioned, the coordinators go into the healthcare chart and collect that detailed de-identified clinical data. So the other thing that we've done is more recently is we've really tried to respond to the evolving needs of researchers. So we've started to do custom prospective collections. So one of the things we can do is we can collect bloods from patients, and we would like to in the future be able to collect serial bloods over time, either preoperatively for patients at risk, or else possibly for patients during the course of their treatment. We have successfully been able to obtain fresh, viable tumor on the day of surgery and ship it overnight to our research clients, where they can take those samples and do drug discovery or generate PDO or PDX models. And then we've also been asked to improve our data collection by using custom forms to collect some of that biomarker data that's on the COPATH report. Really to enhance the value of the samples. So how does one get more information about the Ontario Tumour Bank? We do have a website, and on the website we have a listing of our products and services. And right on the main page, we have a field that says access to samples and data is simple, straightforward. Thank you, Riley, for putting this in. It says start a sample or data request. And by clicking on the button, it takes you to a page where it gives a list of our inventory, where you can select from that, the clinical data fields that are collected, and also the samples and derivatives that are available. So one of the questions we often get asked is, how much does it cost? So this is just a rough idea. So for instance, we do charge for basic data, but for comprehensive full data, we do charge a little bit more. I do want to note that our access fees to academic researchers are subsidized, and whereas we charge full price to our industry colleagues. So for instance, an aliquot of plasma, buffy coat, or tumor costs around $45. I did want to mention also we can, by collaborating with the tissue portal under diagnostic development, our paraffin blocks can be sectioned and processed, and those slides can be made available. And we also, as I mentioned, have scanned images of our tumor library, and these can be downloaded and made available to researchers. So we do have a request process. It's facilitated by our senior client coordinator, Riley, who's sitting right here. So just to give you a rough overview of the request process. So the request is received. It can come through the website or it can be emailed to us. And then Riley would go ahead and run a sample and data search based on the specific requirements of your research project. And then set up a meeting to discuss the cases and to determine which cases are of interest. We have to meet regulatory requirements that include things like research ethics review of the study. The study undergoes an internal scientific review. And we do have an MTA, but we try to simplify the process, and Riley does an amazing job of guiding our clients through the process. And of course, as I mentioned, we do charge access fees. And then depending on the nature of the study, if there's processing involved, we would coordinate that through the tissue portal if desired. And then the samples and data are distributed. The process does take a couple of months, but that's so that we can meet all the requirements to do this under health policy in Canada and to follow regulatory standards. So to give you an idea, oh, this looks terrible. I don't know what happened to it. This is an example of a search that was run. In this particular case, if you look at column 2, it says site of primary, and BRST means breast. So this is an example of some of the data that we can extract from our database. If you just going through the columns, it tells us whether there's frozen tumor or frozen adjacent normal tissue available, whether the blood draw was preoperative or postoperative. Tells us how many vials of plasma buffy coat are available. In this case, tells us the path staging by T, N, and M status, as well as the pathology grade. And for many years, we've been collecting the biomarker, the hormone receptor status of our breast cases. So in this case, these are triple negative cases, and also the age of diagnosis of the patient, whether the patient was pre-treated before surgery, whether the patient after surgery received radiotherapy, whether patient history is available, and the current status of the patient, as well as the progression status, and if the patient has expired, what the cause of death was. I also wanted to point out on the right-hand side, you'll see a link to a digital image. And for each of our cases, we've scanned in the tumor, as I mentioned, and these images are available to our researchers during the case selection process. So it's a matter of signing into objective pathology. We would provide a passcode. And this is an example of what the digital image looks like. It can be viewed on your computer or submitted to a pathologist for review. In this case, this is an example of a triple negative breast cancer that's in our digital archive. So the Ontario Tumour Bank would not have the value that it has without just as a standalone organization. Really, I think the strength of our bank is the fact that we are part of collaborative research resources here at OICR. So if you think about it, we have our sample set and our data set, which is tumor, plasma, buffy coat, and de-identified clinical data. If we combine that to the resources of Diagnostic Development and Tissue Portal, they can do, for instance, tumor DNA and RNA extractions. They can also extract the DNA from our plasma samples and genomic DNA from our buffy coat to serve as control. And then, of course, all of this, the DNA and RNA can be submitted to the genomics program to provide whole exome sequencing, whole genome sequencing, transcriptome sequencing, and bioinformatics. So one of the other things I wanted to mention is one of the challenges that we face and biobanks across Ontario face is how do we serve the needs of researchers best across the province of Ontario and beyond? And I've been involved in tumor biobanking for more than 10 years, and I've met many of my colleagues. And in fact, we now know that there are tumor banks located in Ottawa and Kingston, if you think about the clinical trials bank there. In Oshawa, Lakeridge has a biobank that they've established from their clinical archive. Here in Toronto, there's a really rich resource of tumor banks. So we have the Ontario Tumour Bank here at OICR. Sunnybrook has a biobank, a very strong biobank for hematologic malignancies and is moving into the solid tumor space. Hospital for Sick Children has a number of programs, including a brain tumor biobank from children. University Health Network has an unknown number of biobanks. When I was there, we could never figure out exactly how many there were, but there were many. They've tried to consolidate them, and they call themselves Biospecimen Sciences Program. And then Mount Sinai Hospital has a very well-established repository as well. Hamilton, I mentioned that OTB operates out of Hamilton at St. Joseph's Healthcare, but there's also biobanks at McMaster University Health Center and a large repository at Hamilton General Hospital, and even Guelph. Guelph has a biobank of companion of samples of tumor from companion animals. And then I did want to mention London, again, one of the OTB sites, but they actually have a banking program for other specific tumor sites as well, including ovarian cancer. So, so we had the idea that perhaps it's time that we connected better with our oncology biobank colleagues. So what does that mean? It means that if we could form a network, it would mean that there would be not only solid tumors available, such as we bank, but also hematologic malignancies. In fact, there are 5 hematologic malignancy biobanks that we've identified so far in Ontario. Each of the banks has its own SOPs, and typically they would bank tissue, in some cases cryopreserved cells, particularly for hematologic malignancies. Many bank cell-free plasma and other biofluids. And then some actually have living models, for instance, in Princess Margaret Living Biobank, where they have models, patient-derived xenografts, as well as a patient-derived organoid core. And then we're looking across the province. It's not only cancers from adults, but also from children. And then, as I mentioned, in Guelph, they have tumors from companion animal participants. So what would be the benefit of networking the biobanks, oncology biobanks across the province? Really, what we'd like to do is set up a central catalog and application process. And the whole idea would be that you could go to one place if you were looking for a specific subset of samples. And this would be particularly advantageous for large requests of more rare tumors, or also for larger cohorts. Some studies really need numbers of samples in order to be able to get the power calculations necessary to really answer their research question properly. So just to wrap up then, I wanted to thank you for listening to our presentation.